Okay, two circled equations here. First, the circled equation at the top is an example of a formula or a theorem that we saw. The multi-permutation formula fraction has 20 factorial divided by a bunch of numbers, 3 factorial, 2 factorial. I threw in a 0 factorial, 2 factorial, 1 factorial, 9 factorial, 3 factorial. Those numbers on the bottom have to add up to 20. And directly below there it says multinomial coefficients. That's another name for these. And there's the shorthand way of writing it, 20 over 322,193. And when you do that, you don't have to write the zeros. And in the circle, it shows an example of the formula that we've saw previously, that you could also find that same result by doing 20, choose 3, then subtracting 3 from 20 to get 17, choose 2, and then subtracting 2 from 17 to get 15, choose 0, and then 15, choose 2, since 15 minus 0 is still 15, and then subtract the 2 to get 13, choose 1, and then 12, choose 9, and finally subtract the 9 to get 3, choose 3 as the last term. And those count, as I put to the left, the number of anagrams or multi-permutations. And in this case, I did pick an arbitrary collection of numbers, 3, 2, 0, 2, 1, 9, 3, just to demonstrate that this is counting one possible multi-set. The letters in a big nonsense word, the anagrams of that set. Let's see. Oh, and then on the right, it's also a number of ways to choose. Exactly 3 books for shelf 1, 2 books for shelf 2, 3 books for shelf 7, and all those other numbers in between. There would be 9 books for shelf 6, and putting them all in unordered piles. Now, briefly compare that to the number of ways to distribute 20 books on 7 shelves in unordered piles. That's just one way of doing it, but it's the number of ways to do it if you pick that number of books for shelf 1, that number of books for shelf 2. So you can tell now that the summation would give you the right answer, at least after thinking about it for a few minutes. The number of ways of distributing in any size piles should be the sum of the number of ways of distributing in a given size for each pile. And the given sizes for each pile is the plan for the shelves. And then finally, there's the number of ways to put 20 books on 7 shelves in precise order. So the way we thought about that at first was to make a plan, count all the ways of making a plan for the books, and then start placing the books. And doing so that gives you that 20 factorial, because there will be 20 locations in your plan for the first book, then 19, then 18, all the way down. But then you can simplify that a couple of different ways, as I put underneath there. Again, the summation here is a little redundant, because what it says is just add up 20 factorial a whole bunch of times. It doesn't change ever. It's just 20 factorial plus 20 factorial plus 20 factorial plus 20 factorial. But the number of times you add it is given by the number of ways of finding J1 through J7 that add up to 20. And so that's the multi-combination again. All right. Now for examples.